Okay, I'm having a look at a quiz for 11 Maths Methods. We have started on our Unit 3 work. So this is covering some topics from Unit 2 in terms of chain rule, product rule, quotient rule, but we have also looked at the derivative of e to the x, and we have been revising our solving logs and solving e to the x. So that's what this quiz covers a bit of. So the first one we've got is solve for x. And we have 2 to the power of 2x minus 6 times 2 to the x plus 8. Now, these are one of my favourite ones because they're like a bit of a trick question, or you need to be able to notice what you need to do for it. So the trick, I guess, that you're looking for is when we see a 2x like this and we have another something to the x, we can write this one as 2 to the x squared, because x times 2 is 2x. And then we've got 6 times 2 to the x plus 8. And what we've got here is a quadratic. So I can say let 2 to the x equal a, and I can write that as a squared minus 6a plus 8 equals 0. So then I can factorize that in that format. So if I've got a quadratic, obviously I've got a, b, c coefficients. My ac is 8. My b is negative 6. I'm looking for two numbers that will multiply to give positive 8 but add to give negative 6, which are going to be negative 4 and negative 2, because they will add to give negative 6 but multiply to give positive 8. Once I've done that, I can say that a must be equal to 4 or 2. Once I've solved for a, I can put that 2 to the power of x back in. So 2 to the power of x must equal 4, or 2 to the power of x must equal 2. Now, if 2 to the power of x equals 4, I know that 4 is 2 squared. So I can write, and I'll bring that up over here, 2 to the power of x must equal 2 squared. Then I can do what we call equating the indices and say, therefore, x is equal to 2. If I've got 2 to the power of x is equal to 2, I know that's the same as 2 to the power of 1. Equate the indices, then x must be equal to 1. I always want to do a double check, not specifically here, but if you get two solutions, always check that they both work in anything like a log. If you end up with two solutions, making sure that you don't end up with a negative in there. In this case, we've got exponentials, so that's not a big deal, but always be wary to check that both solutions work in the original equation. Down here, we've got a log equation that we're solving. Now we've got all log base 10. So first I'm going to bring these two together, but I want to take this 2 up to the top first. So I've got log 10x plus log 10 5 squared is equal to log 10 6. Now I'm going to bring these two together. When I'm adding, that means I've got to multiply what is there. So I've got log base 10, and I have x being multiplied by 5 squared, and that's what log base 10 6 equals. So I can write that as log 10 25x is equal to log 10 6. Now if I've got the same base, then I can say that these two must be equal to each other. So 25x is equal to 6. To get what x is, we can put 6 over 25. Now if it did come out as a nice round decimal number, we could also list it as that, or we can leave it as our fraction. So the next one has ln. Now our ln rules work the same way as our log laws, where if we're adding, we can multiply. So, but just like up here, the 2 out the front needs to go up to the top first. And now we can multiply these two parts to bring that together. So ln of ax squared is equal to 0. This is where we then use our log laws that we learnt back in Unit 2 to know that if we are getting a 0 here, this part must be 1, because anything to the power of 0 is 1, and where ln means log of base e, so we would have to have log base e of 1 to give us 0, therefore ax squared must equal 1. Then we can solve for x squared, so we can divide by a, x squared must be equal to 1 on a, therefore x is equal to plus or minus the square root of 1 over a. Number 2 is a sketching question, and it's always important to know when you're sketching your graphs. You can, if you've got your calculator with you, you can be using that. This quiz was not a tech-free quiz, so calculators were allowed. We can just pop that in our calculator and get what it should look like. So here's our ln button down here, ln of 2x. We can graph that, and we can see that basic shape there. So we can do our little sketch But the things that we're going to want to make sure we're showing on that sketch is if there's a y-intercept and an x-intercept. Now we can see it stops at that point. We're assuming that that asymptote is going to be on the x equals 0 line. We want to know this x-intercept though. So to get that, we can use our second trace and we can find what we call the 0. So that's when x equals 0. We have to tell it where to look. So that's the one thing the calculators need help with. I'm going to tell it, I know that my window is between -10 and 10. So I'm going to tell it to look between 0 and 10. Oops. And then I just have to press enter again. And we can see that that is going to equal 0.5. That's where that is cutting there. We want to make sure we've got our x and y's on there. We want to make sure that our graph has a little arrow there, and we would usually write the name of the graph on there. If we were looking at one where we wanted to talk more about the shape of it, we might also compare it to just an ln x if that was part of the question to describe anything more about it. But otherwise, they're the key features that we are looking to show on that graph. The next side of the sheet is all about derivatives. So I really wanted to revise those derivative topics with my class. I've thrown in a polynomial one just to keep that process of our polynomial derivatives going as well. So because we're learning about e to the x at the moment. Here we've got our 5x squared. So our y dash is going to be 10x. And then here, that's the same as 3x to the -1. So that means we would get -3x to the -2 would be its derivative. This is the same as x to the half. So then I would bring down that half, and that would be to the -1/2. I would then want to always write my answer with positive indices. So I'm going to leave my 10x like that. I will have my 3 over x squared, and then I'll have 1 over 2, and then that would be the square root of x to take that to the bottom. Next we have our e to the x and the derivative of that. So that's what we've been looking at this week. So we have been learning about how we find the derivative of that power. So the derivative of 3x is 3e, and that power stays the same. So that's our rule for doing the derivative of e to the x. Then we've got this question here, and I've put some little hints down the side of reminder this is going to be using product rule. So I've got my y equals u times v. Over the side here, I'm going to use u is equal to x squared plus 3. V is equal to e to the 3x plus 1. So my u dash is going to be 2x, and my v dash is going to be, and I did that question up the top here, so I know that answer is 3e to the 3x. Now I'm going to write my y dash is u dash v plus v dash u. So I have 2x outside of e to the 3x plus 1, and I've got 3e to the 3x outside of x squared plus 3. Now I could expand that and collect like terms, so I have 2x e to the 3x plus 2x plus 3x squared e to the 3x plus 9e to the 3x there. Looking along my line, I've got this one with the e to the 3x, but it's got a 2x in front, 2x, e to the 3x, x equals 3. So not really anything I can bring together, so I could have just left it in this form rather than this one here. For D, I've put a little note here, we're going to use chain rule. So we've got 3u to the 4, where u is equal to x squared plus 3x. So dy on du is going to be 12u to the 3. Du on dx is going to be 2x plus 3. So then my dy on dx is going to be dy on du times du on dx. So I will get 12u cubed being multiplied by 2x plus 3. I'm going to put that u back in. So I've got 12. I'm going to pop this 2x plus 3 at the front. Then I'm going to put my u back in, which was x squared plus 3x, and that's raised to a power of 3. My last one here is my quotient rule question, and I've popped in a little e to the x on the bottom there. So I've got y equals u over v, where u is equal to x squared plus 5x, v is equal to e to the x. My u dash is going to be 2x plus 5, and my v dash is going to be e to the x, because the derivative of e to the x is e to the x. So my y dash is going to be u dash v, take v dash u over v squared. So I've got u dash is 2x plus 5, and my v is e to the x, so I'm just going to pop that in the front. And then v dash is e to the x, and my u is x squared plus 5x. And then on the bottom, we have v squared, which will just be e to the x all squared. So we can write that as e to the 2x. And on the top here, we do have that common factor of e to the x, so we could also bring that to the front. And they each have an e to the x, and there's one on the bottom, so we could cancel that out as well. So that actually would be easier. So we can actually cancel out an e to the x here, here, and here. So we end up with 2x plus 5, take x squared plus 5x over e to the x. And then we can bring together the 2x. Now that is a minus all of that, so that'll be 2x minus 5x. So we've got minus x squared minus 3x plus 5 all over e to the x.